It's now time for our speaker. It is my pleasure to introduce our speaker, my friend, Kurt Schmitz. Kurt was a staple in my house every evening that I was home, providing his weather insights for 21 years at WTVM and another 6 years at WRBL. And that was before the Weather Channel and AccuWeather, et cetera. So those were so ubiquitous. And we depended in those days on our local weatherman. I grew up trusting Doug Wallace. Those of you old-timers like me remember Doug Wallace's nightly weather forecast. And his back in those days, there were no computer graphics. He put everything on a chalkboard, and he had that characteristic flip. Remember Doug? But shortly after Doug Wallace retired, Kurt Schmitz showed up and proved to be a very capable, high-tech replacement or stand-in for Doug. So as an adult, I learned to lean on Kurt. Kurt now teaches classes at the Columbus Academy for Lifelong Learning, where, in my opinion, he is the most prepared and most engaging course facilitator there. He's taught numerous science courses there, most recently a series on physics, but he always manages to work in weather developments. So please help me welcome Kurt Schmitz. And my computer has a mind of its own here. I'm going to...
Show me where that video is.
My video, I'll download it.
Okay. I guess I'm not going to be able to put it in the presentation, but yeah, we'll get to it in due time. Okay. Well, good morning, everybody. I see a few familiar faces here, some from the call group. Yeah, I've been retired now for it's about 8.5 years, believe it or not. But that doesn't mean I don't follow the weather. I still do, but it's a hobby and I don't get paid for it anymore. Other things, I do the program, as Ron mentioned, with the call group, and I'll do another one this fall, which does not involve weather. It's more of a history thing. So we've got others in the group who do that stuff really well. So that'll be a challenge. Of course, I'm going to work weather into it one way or another. So if you'd like to join call, I mean, feel free to do it. We have plenty of interesting things going on. I'm also a rock and roll disc jockey for 4 hours, a 4-hour show every week. That's a whole nother story that I won't get into, but it's something that's fun. I don't get paid anything for it, but there's an interesting story behind it. All right, let's see where my program is here, Ron. At the bottom.
PowerPoint.
Ah, here we go. Oh, okay.
We got to switch the computer screen. Excuse me one
Oh,
second.
okay.
Windows key P to Windows key P to duplicate. Did that take? No, it didn't. Hang on a second. Oh, wait, we're up there. Okay.
All right, let's get this thing started here. I'm going to talk today about heat, fires, global warming and climate change, and El Nino. Okay, here we go. Yeah, I got to go to this thing. There, right? No. Okay.
Oh, I see what's going on.
The timing's on there.
Anyway, I mentioned those things that I'm going to talk about. El Nino was the last one, and believe it or not, they are all connected. Okay, so I think it would help if I did this first. There we go. Yeah, all right. Yeah, maybe you've heard of Isaac Asimov. He's a great science fiction writer, among other things. I believe in observation, measurement, and reasoning confirmed by independent observers. And he says he'll believe anything, no matter how wild and ridiculous, if there is evidence for it. The wilder and more ridiculous something is, however, the firmer and more solid the evidence will have to be. That sums up his view on science. questioning the science is important, but so is accepting the answers that science provides. We're in a time where science has taken a hit, and it's kind of under siege in a way, and that's due to political reasons more than anything. And science progresses by accepting and building on answers rather than asking the same question over and over again. Once numerous, large, well-conducted studies have converged on a result, continuing to doubt that result is denial, not questioning. I hear a lot of denial nowadays, but that kind of sums up where the state of science is today. We got weather and we got climate. They're not the same thing. Weather is what you experience when you step outside, the short-term state of the atmosphere, any particular location. Climate is the average of the weather patterns in a location over a longer period of time. So obviously they're related, but they're just not quite the same thing. Now I want you to watch this carefully. I can't stop it at the end, I found out. It's a GIF frame. But this is something that's kind of misunderstood, because you will hear people say when we have a heat wave or something, that, or a cold wave, yeah, we always had heat waves. We always had cold waves. This isn't anything different. It is. And this graph tells why, because the bell curve you see there, the average is in the middle. What's happening under our current changing climate is that we're seeing more heat and we're still seeing cold, but not nearly as much. So the whole average is moving, and what that happens is results in a new normal, you might say. Last week, 1 week from today, we had an incredible heat wave out west. It got up to 109 degrees in Salt Lake City. Many of you have been there and find it hard to believe maybe that it got up to 109, but it did break their all-time record. Not just the record for the day or the month, the all-time record. These were some of the other temperatures that were reported, and I apologize for this being difficult to read, but it was the best one I could find that showed these temperatures. But we're talking about, where is this here? That is Billings, Montana, and that's 111 degrees. Some of you have been to Montana, Yellowstone Park, that area. Billings is not far from there, 111 degrees. This is Miles City, Montana, and that's a 115 degree temperature there. That's 103, and that's Bismarck, North Dakota. So this was an incredible hot spell. Notice too that Billings was hotter than Phoenix. Phoenix is down here. And here's Salt Lake City and other places in the valley there. In Utah, we're above 100 degrees. Records smashed all over the place. So that was an extraordinary event. And it's safe to say that without a changing climate, that would not have happened. The probability, infinitesimally small. It's not the only area. The Northeast, a couple of weeks before that, was shattering records all over the place. Maybe not as extreme as what we had out west, but there is a spike which shows what has been happening in the Northeast. There's going to be more of this the rest of the summer too. It's just a matter of where. And we have fires. That's in the news now, because these fires have originated up in Canada, and the wind patterns have brought it down here into the United States. And let me tell you, they're suffering. I've got relatives in Wisconsin, and they're saying they have never seen the smoke that bad. And it literally is hazardous for one's health. And this is a map of all the fires that are going on throughout this region of Canada. Fires are a normal thing up there in the boreal forest, but never to this extent, and it's been going on now for several years. We've had this over and over. There's a look at the boreal forest up in Canada, where the trees pretty much dominate the landscape up there. The red dots are areas of population, concentrated population. But that's a situation up in Canada, and there's a reason why it's happening more often. The climate is becoming drier up there, and it's becoming hotter. And the trees and the entire ecosystem around there can't handle that. Most of them are started by lightning, but there could be other reasons as well. So this is something that we're going to see more and more, and smoke can be hazardous to your health. It happens in the United States too. Check this out. The amount of acres that have been burning across the western US has increased dramatically. And you can see there's the line of best fit right there. And it has, to go along with the temperature rise, so have the fires. Too bad you can't read that little fine print on there, because that tells more about what the graph is. But without getting too much into that's basically what's been happening. Now, summers, they've been getting hotter. No doubt about that. And I'll say that this is based on what weather people consider normal or average, and it's based on a 30-year average. In this case, from 51 to 1980. That's 30 years. So this is how it looked back in 1976 compared to that normal. This is how it looks in 2022. It's getting hotter, not just in the United States, not just North America, not just the Northern Hemisphere, all over the globe. Back home here, this is a key too, because we've always had hot days. But how about the nights? This is where it shows up even more dramatically, that we have had major changes in the June and July temperatures, minimum temperatures, lows. And you can see how extreme that has been. The valleys of California, all over the Southwest, New Mexico, Arizona, even here, even around here, Columbus right here, been marginal, but the same trend has been seen nationwide. And this is what they call the hockey stick graph. You've probably heard about that. It was introduced maybe a good 40 years ago or so. These are the reconstructed temperatures going back 2,000 and some years. Yes, yes, they can do that reliably using a number of methods. But this is where you'll hear people say, well, okay, the climate has always been changing. But that is not true. It has never been changing like this, never. And the reason for that, the way it's changing now, is because of what humans are contributing to the planet. And look, it's been relatively stable for many, many years, even cooling a little bit. And look what it's done in the last century. These are the temperatures. There's your hockey stick. The temperatures, the average global temperatures, have soared since then. Oh, you want to see even more? Well, we can go back 20,000 years. And there is some uncertainty here in this area, but they have a pretty good idea. But this links it to a number of events that have happened. The last mammoth in North America, right there. Then the climate has been warming. You go back here, you're talking about the Ice Age, so obviously. And since then, we've been kind of maybe cooling a little bit. There are large-scale reasons, astronomical reasons for that. Stonehenge is right here. Recorded history started right here. And since then, it's been relatively stable. You've got several warm periods, including medieval warm period. You'll probably hear a lot about that. It's right in this area here. And then all of a sudden, here we are. It probably has not been this warm globally for 1 million years, at least. They don't go back to 1 million years, but they're working on that. Oh, Columbus. Has it been warming here? Yeah, sure it has. I got here in 1989. This graph goes back to 1970, and look, slope is upward here. The jagged lines, of course, are individual years, but if you fit a straight line to that, that's what's been happening. Average temperature in the summer months, that's June, July, August, 1.9 degrees higher. Doesn't sound like much, but when you average it out, it's significant. And I mentioned the minimum temperatures. Sure enough, Columbus has had warm summer nights. I noticed that without even doing the research, that our nights are getting warmer here since I've been here for 38 years now. And of course, this is climate change fueled. We're talking about now daytime highs, the extremely hot summer days. The benchmark here is they're classifying extreme heat as a maximum temperature above 96.7. You can't read that there in the fine print, but that's what it is. So we've had more, not that many in the 1970s, and look how that has soared since then. So we're seeing it in the daytime as well as at night, and more streaks of extreme heat. That is 3 or more consecutive days with temperatures above the 90th percentile. So we're getting more streaks as well, more heat streaks, that is days in a row where it's really hot. Rainfall intensity, it's not as dramatic here, but that's also a factor. It can be attributed to man-made climate change. The slope of this line is not dramatic, but when you fit the curve to the line, it is up a little bit, like 3%. It's another important thing is that a warmer atmosphere holds more water. More water results in more rainfall and more intense rainfall. Longer growing season, longer allergy season. Maybe you have problems with allergies. And this is a graph of the freeze-free seasons. So we're up 15 days where we have not experienced freezing temperatures. Oh, and this one is another one of those things that I could notice just looking at data without even doing a thorough analysis. Winter's getting shorter by 8 days here. The average days at or below 53.3 degrees Fahrenheit, and you could plug in several other temperatures and you get the same effect. But right now, winter is about 8 days shorter when you define it that way. Not by the calendar, but by the temperatures. And also we've had more extremely warm winter days, and those are defined as, again, above the 90th percentile. So we're having 3 more warm winter days. A lot of people like that, but it's just an indicator of how things are going. Oh, and this is one of my favorites. This is a comparison of the record highs to the record lows. We're going back to 1950 here, and there were more record lows than record highs. Look what has happened. This is one, I think, of the best indicators of how the climate is changing. We're seeing many more record highs now than we used to see, and fewer record lows. It doesn't mean record lows won't happen. We might hit a record low on a particular day. That doesn't mean that the climate is cooling or anything like that. Oh, and I always like this one. This is, I hear people say that, well, it's not humankind that is causing the climate to change, it's the sun. Come on, here we go. The claim, it's the sun, and it's, yeah, we're on Earth, and we live here, and who really controls the climate? Well, the data shows, no, it's not the sun. The sun's energy, and they can measure this very precisely now, has been dropping. The temperature, that's going way up. So we're actually getting less energy from the sun. And the temperature continues to go up. And that obviously is due to the greenhouse effect. And the greenhouse effect is being caused by fossil fuel burning and other greenhouse gases going into the atmosphere. All right, that covers a lot of the climate change in a nutshell, I think. So let's move on to El Nino. You've probably heard a little bit about that lately, and if not, you certainly will, maybe more than you want to hear about it. Because the question is, do we have a super El Nino coming? El Ninos happen every so often, and it has to do with the ocean temperatures. This actually is a global sea surface temperature, and notice how warm it has been this year. Well above the blue line, which is the mean since 1991, and these other squiggles are various years. We've seen it since 1982. There have been some pretty good ones since then. We had some El Ninos, 82, 83 was an El Nino, 97, 98 was the big one, really, in my career. And sea surface temperatures continue to rise. This one goes back to 1982. It's plotted year by year here. So that's another indication of climate change. We've got that warming ocean. Warming ocean leads to more moisture, leads to more rain, and more heat. The oceans drive our weather, maybe more than you might think initially. And these are the zones that scientists used to measure. This is where El Nino originates. And it's this Nino 3.4, the area that they usually look at to determine whether we've got an El Nino coming or not. In a normal year, this happens. We have that push of warm water back to the west toward the Pacific Islands and Australia. You've got cold water along the coast of South America that suppresses rainfall there. and keeps the fishermen employed. In an El Nino year, it's completely opposite. We have a strong push of warm air that goes all the way to the Mexican and South American coast, and that results in a warmer winter, among other things. I'll get into that too. So here is that push of warm water, and they're seeing it on the way already. The real question right now is it affecting our weather currently? And that's still maybe open to debate. And this is supposed to be a video, and I do not understand why it doesn't play, but I want to throw this short video in here. Anyway, I can play it like this. I'm not sure why it doesn't play, but this is it. And we don't have any sound. Okay, give me a signal when you've got the sound. Well, I could skip this if. Okay, let's try this.
Warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Nino. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean.
Oops. Whoa.
East to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Nino. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern U.S., and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Nina, unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Nina can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Nino and La Nina together are part of a cycle that influences extreme weather and can impact food production, water supply, and even human health, not just in the U.S., but in many parts of the globe.
Okay, that's introduction to the scientific basics of El Nino. Another video here which is going to go into a little bit more detail. Now keep in mind that this...
Experts released their...
Okay, this comes out of a Sacramento television station, so it's kind of aimed toward California, but it kind of
outlook on El Nino.
Yeah, scientists at the National Oceanic and Atmospheric Administration, or NOAA, say the pattern is getting stronger. KCRA 3 meteorologist Heather Waldman explains what this means for our region. Heather?
Yeah, it's getting stronger, and it's getting stronger quickly, too. Remember, when we're talking about the strength of El Nino, we're just talking about the water temperatures in that specific part of the Pacific. How much warmer are they compared to normal? Well, this month, we're now in what's called a moderate El Nino. Last month, El Nino was still in a weak phase. So again, getting warmer, getting stronger with each passing week. By the time we get to late fall and winter, a very strong El Nino is now the most likely scenario. Last month, 63% chance that was going to happen. This month, we're now at an 81% chance of that happening. And we're likely to still be in an El Nino as we go into 2027, although through the spring, it's going to back down in intensity somewhat. Now, a month ago, I told you that a very strong El Nino pattern does tip the odds in favor of a wetter than normal winter in Northern California and in California in general. This is what one ensemble model, so a bunch of different models together, all putting together one forecast. This is what it's showing for right now for December, January, and February. Meteorological winter, areas in green that you see here across the Southwest, that's pointing to the possibility of wetter than average conditions.
Our area too.
Here are the caveats that go along with that. We're talking about 5 months away. There is time for that to change, and an average or even a dry winter is still a possibility when we're talking about a very strong El Nino. So I just showed you the overall pattern for the winter, the possible pattern for the winter, but when it comes down to the impacts that you and I care about, how strong are the storms? When are they coming through? How far apart are they spaced? Are they warmer? Are they cold? Those are the details that matter to us and that impact us most, and those are details that we can't see until we get into that season itself. So we'll keep tabs on this, but first we'll send it back to you.
All right, thank you. If you want to learn more.
Okay, so that kind of brings us up to date on what's going on with that. It's almost a certainty there will be an El Nino type event coming this winter, and fall and winter. The exact impact is open to debate. She said 81% chance it's going to be a very strong El Nino, maybe even the strongest in the last 150 years or so, they're saying. But that is not a certainty. One way or another, though, we will have some of the El Nino effects. For Columbus, the ones that I remember most are the 1998 one. We had a very wet winter, cloudy, cool, rainy that winter. The most recent one was 2016, and what I remember about that is we had a shocking amount of rain in December. Maybe you remember that when we had severe thunderstorms around the area on Christmas Eve. I sure remember that. I was still working then. And it broke a record for the wettest month in the city's history, December of 2015. So that's maybe what we're in for. We'll wait and see. Scientists are keeping tabs on that. All right. Let me. Come on. Oh. Here we go. Slideshow. There we go. Okay. So this is another explanation of the same thing. You can see how southern tier of the United States is going to be wet and somewhat cool. Isn't the best graphic, but this is the best one I could find to indicate what's going on here. Warmer up here to the north, the jet stream suppressed well to the south, the polar jet getting shunted off into the eastern Canada and the North Atlantic. So it's something to look forward to. You'll be hearing more about El Nino, the storms in California, the storms over the southeast, and general disruption and everything. The real question is, how much is El Nino related to climate change? They are connected. They're not sure exactly how, but if this turns out to be a super strong El Nino, then they'll have a better idea that climate change is playing a role in this. Okay, if you want to read more about this is maybe the best book that I've read. Scientist Michael Mann, he's the one who originally came up with that hockey stick graph. And he wrote a book recently. He's got a new one since then, but this is the one that I like the best. It's called One Fragile Moment. Don't know if the library here has it or not. If not, they probably should. And there are other sources that I rely on. These are some of the most reliable ones. These are scientists who I know understand the situation and I could trust for updates and things like that. This is the best website you will find, climatecentral.org. It's independent, it's not connected to the government. Government is trying to suppress anything on official sites that have to do with climate change, and you probably know why. This guy is on Twitter. I don't know if you use Twitter or not, but that's where a lot of the information comes out of. You just have to be very selective in what you read on Twitter. But this guy is reliable. This is actually my favorite, Professor Catherine Hayhoe. She also has her own site besides Twitter, and that's it right there. And this guy here is another one who is reliable when it comes to information. And there are more. There is a handout that Ron has placed. Here it is, and that gives even more sources for good, accurate information on this. They include the PBS series Weathered. I've been known to use that in my call presentations because it's so good. And they do a good job of explaining a lot of interesting things about how things are going. And you can pick one of these up. Ron's got them in a pile somewhere on one of the tables. So on your way out, pick one up and you can investigate that yourself. My role as a broadcast meteorologist, even though I'm no longer working as one, is to inform the public about the science. And I stick to the science, avoiding the politics, although it's becoming almost impossible to avoid the politics. But that is my objective and the objective of many broadcast meteorologists. It's been a big push through the American Meteorological Society for broadcast meteorologists to kind of take the lead in this department. I'm not on TV anymore, but things like this, other presentations, I can continue to present the science as it exists, and it will continue to be updated because that's what science is, as I said in the beginning. We're always learning something new about it, and it continues to be very extensively researched. That's what I got, Ron. I want to thank Ron and Connie for suggesting that I come out and talk to this group. You're always a great group, and I always enjoy coming out here to talk to you.
Would you mind taking a few questions?
Oh, sure. Any questions? Yes.
One second.
I read that global warming causes the ice age. Is that true? And if so, can you explain how?
No.
Okay.
No truth to that whatsoever. The ice age is a completely different thing. There will be other ice ages on this planet, but we got to survive first. And I mean, we're a couple thousand years probably away from the next one, if it goes according to the usual pattern.
How does El Nino affect hurricanes?
Very good question. I didn't have the time to get into that in this presentation, but I'll try and sum it up for you. The El Nino situation, and it's questionable how far we are into it right now, but if we are into it at the moment, it serves to suppress hurricane formation in the Atlantic basin. Due to the fact that the upper level winds are stronger and provide more shear, which doesn't allow the hurricanes to form that easily. That doesn't mean they can't form. They could. In fact, we might have a little tropical disturbance down the Gulf very soon. But that's how it'll affect the Atlantic. It tends to suppress the hurricane season to be lighter than normal. But that doesn't mean there can't be a destructive hurricane in an El Nino year. All it takes is one to hit the right spot. But I would look for fewer hurricanes and tropical storms this year. And in fact, the official predictions have taken that into account already. Now, it does tend to amp up the season in the Pacific, the East Pacific, and that's because of the warm water over there. Water is much more warmer than normal. Yes, Connie?
I'm just wondering, since apparently the effort to clean up fuel from those great big tankers that are, going back and forth with oil tankers especially, might have caused some lessening of greenhouse effect and more sunlight getting into the ocean and causing more ocean warmth. That's what I've read. Are there things that we can do and think we're doing something positive, maybe, and that really do turn out to have an immediate reaction that is positive?
Ron kind of brought that up when I came in this morning, and I had not really been familiar with what he was talking about there. He sent me a link, so I'm going to check it out. But I don't, this is human caused, and the solutions are there. We just have to have the political will to do it. Other countries are getting way ahead of us in developing clean energy and getting off of fossil fuels. But I mean, we're the world leader in just about everything. We need to lead the world in that too.
Kurt, why don't we have the political will to face this problem?
Now you're getting into the politics and that. I don't know. I could say that as a population here, we're not terribly scientifically literate. And I think if more people were, that's what we're trying to do. We're trying to get the facts out there and get people to understand what that's all about. But that probably is a contributing factor. There are other things too that are more on the political side of the spectrum than anything else. And I won't get into that. I'm going to stick to the science. But I think a push for scientific understanding is always welcome.
Hey, I'm Emad. I'll actually be focusing my talk in 2 weeks on climate change and surgery. So really interested in what you just presented, and hope if you have time to have you come and listen to that too. But I was wondering if you had like knowledge into certain avenues we could get involved on climate action locally in the Columbus area, and on all levels.
That's a really good question. And the first thing that comes to mind is we need more electric cars. You know, there are certain countries in Europe, I think Norway is among them, where most of their car sales are electric vehicles. China is one of the bigger producers of electric vehicles. I can't vouch for the quality of the cars, but we don't import them here yet. We could probably do that. And we could have more charging stations. Technology is going to continue to improve, I think, and that definitely is our future. Fossil fuels, I may not be around long enough to see it, but there will be a day when fossil fuel cars will be a dinosaur.
If I could add to that, there's a very active chapter of the Citizens Climate Lobby, CCL, out of Atlanta. And we had an active chapter in Columbus. Actually, we used to meet in this building. I myself and some former members here lobbied Drew Ferguson, our former congressman, and Drew wouldn't hear of it. He would not acknowledge any iota of climate change being a real thing. He said, yes, getting warmer, but it's got nothing to do with man. It's just natural cycles. And we went back to him and to his aides and presented the science as best as we could, and they weren't hearing it. They would not accept it at all.
There's a thing called Dunning-Kruger syndrome. Some of you may have heard of it. It's where people think they know more about something than they really do, and when you try and hit them with facts, all they do is defend their position.
What puzzled me was that Drew Ferguson is a dentist. I mean, he's a scientist. And we couldn't get to the first step with him.
We do have a connection here with Clean Energy Columbus, which is an activist group, really involved in the local and state level, and that is through the DeFelice Antonio family. If I can give you that contact information if you like.
But Citizens Climate Lobby is worth looking into. I got so discouraged by total lack of progress on the local level. However, Michelle Majette did, I went to Drew Ferguson. Michelle was assigned to work with Sanford Bishop, and she made progress. Sanford was very open and helped us. But CCL, you know, perhaps you would be a young, energetic person to get CCL going locally again.
I actually did meet with that group one time. I don't know when that was, maybe 5 years ago, but I have not heard much about them since then. Yeah, we need a little more activism.
It was Bill Harlan directed that, and he moved away, so.
Yeah, Bill was our local head of that organization. Other questions?
All right.
Have time for
Okay. Okay. On another note, my dog is terrified of thunder, and it seems to thunder so much more here than it did when we were in the north. Why is that, and can you make it stop, please?
Well, it's because our climate is warmer, and we are one part of the country that gets a large number of thunderstorms. Maybe not as many as Florida gets, but you know, we get thunderstorms in the winter up north. I'm not sure where north was, but they don't get as many in the winter up there. It's really rare. But we can get thunderstorms year-round around here. We're, you know, a high concentration of thunder and lightning in the southern Gulf states.
Along that line, add-on question, lightning rods. Should we have lightning rods on our buildings?
I guess it depends on the building, but I think it's never a bad idea to have those. I mean, if somebody could afford to put the lightning rods up there, I would do it in any lightning prone area, like here.
I've noticed out on Post, there are a million lightning rods on Post. Every little shed has 8 or 10 or 12 lightning rods. But this building doesn't have one. Our building next door doesn't. My house doesn't. I would bet you that 9 out of 10 or more of your houses lack them. But they used to be fixtures. But Fort Benning believes in them.
Yeah, again, you know, that's run by the Army and by the government. I mean, and they've got the money to do that. I don't know, for individual homes, it is that cost effective, but for commercial buildings, I mean, like the Aflac building, it wouldn't be caught without a lightning rod system. They could.
$1,500 for a private home.
Yeah.
My neighbor's house was struck by lightning last year, and they had to rebuild, and they did not put lightning rods on it, but they knew the price. I wouldn't have done that.
Yeah, that's a pretty big investment, considering that you can use it for a lot of other things on your house.
Thank you, Kurt.
Thank you, Ron.
Appreciate it.